In the last period, we have studied about the ion exchange resins. We have seen that we need to pass the water. If we use the sodium salt, then a single pass is okay. But if we use the uh, RSO3H or RH, then first we'll have to pass it through the cationic resins, and then we'll have to pass it through the anionic resins, which is our RNH2 anionic. When we pass through the cationic resins, we get H plus. When we pass it through the anionic resins, we get OH minus produced. This H plus and OH minus, when they combine, they gives us the water, and thus we will have the demineralized, deionized water by passing it through the cationic and anionic resin. Each time we get these ions, and thus the neutralization takes place. Now we have the two type or two various resins that we want to regenerate. So now we want to understand the process of regeneration. We have seen that after cationic pass, we have R2M that is produced. And after the anionic pass, we may have RNH3 X minus that has been produced. So if we allow it to react with acid RNH3 X minus, let's say we have allowed it to react with the acid HCl. What happens? We get RH, R combined with this H. Then this NH3 turns out to be as NH3 like ammonia, and then we have this, or we can say that when it reacts with acid, my dear students, we get RH, then we have Cl, and this Cl, yeah, we get ammonia and we get Cl2. So this is what it happens. And when we allow this R2M to react with any alkali, let's say it reacts with NaOH, that is base. So we get RNA, we need 2, so we'll get 2RNA. And then we have MOH twice. We know that this M is Ca plus 2 or Mg plus 2, and that is why this Ca plus 2 and Mg plus 2, my dear students, this Ca plus 2 and Mg plus 2, they will give RNA, that is 2RNA. We need even 2 NaOH, and we will get MOH twice. So this is how we get the RNA back, we get RH back. Here, instead of converting into the RH, we can even understand it this way, that we get, instead of this, suppose we have RNH3 X minus, and if we allow it to react with acid HCl, let's say, so we will get RNH2, which is our anionic resin RNH2. Now we have again this HNCl, the extra H that comes out will give us HX minus, and we will get HCl formed. So we can even think about this, that by the, so let us understand the regeneration once again. You can see that we can have the regeneration, we can regenerate the cation, we can regenerate the anion. The cation is regenerated by treating it with the dilute acid, and anion is regenerated by treating it with the dilute alkali. Your alkali is NaOH or any other base. And you're treated with dilute acid, maybe your HCl dilute. Even the cationic resin can also be obtained by the reaction with NaCl. That is what we have studied into the first point of this method. Let's move back and understand it. You can see that the cation exchange resins that can also be regenerated by allowing it to react with the NaCl. That's what we have seen. Uh, Let me bring it that to, yeah. The resin can be regenerated by adding aqueous NaCl solutions. So if you have R2M and if you add NaCl solution, what you are going to get is RNA, 2RNA and MCl2. So now if you, instead of NaCl, if you have HCl and if you have R2M, my dear students, then you will get, let both are taken as a two molecule, so you will get 2RH and you can get MCl2. So this is how we can regenerate the cationic resins, and we can even regenerate the anionic resins by this method. So these anionic resins, when RNH3X minus, when it is so here I made mistake. Actually, we need to allow it to react with the alkali rather than acid. So we will allow it to react with the alkali, my dear students. So our NH3 plus and X minus will react with alkali like NaOH, and it will give us RNH2. We'll get RNH2, so H is produced from this. We'll get NaCl or NaX minus or NaX, and we'll get H2O. So the extra H which comes out from this, which makes it RNH2, combines with the OH to gives us water, and we get Na combined with X minus to give NaX. So this is how, my dear students, we can easily understand the regeneration. My dear students, I want to make you understand this regeneration process very well. So this exchange, cation exchange resin, which is formed into form of the MR2, anion exchange resin, which is formed in the form of RNH3 plus X minus. This MR2 is allowed to react with a dilute acid. Let's say dilute HCl is used. It is allowed to react with the dilute alkali. So let's say NaOH is used. From this MR2 and HCl, we will get RH. For that, we need to use both the two molecules. So RH we get, and then this MCl2 we get because we have a M as a Mg plus 2 or Ca plus 2. Same way, my dear students, this RNH3 plus X minus is converted to RNH2. So this RNH3 plus, when it is converted to RNH2, it makes H plus. This H plus combines with OH minus to give you H2O, and we get even NaCl. And this is how our original anionic resin RNH2 and cationic resin RH can be produced. Now we can move and understand the next part. Now, my dear students, we want to study about the heavy water. So let us study about heavy water, which is known as D2O. It is extensively used as a moderator in the nuclear reactors and in exchange reactions for the study of the reaction mechanism. Now, what is this? Let us try to understand. Suppose first use is the use of this heavy water as a moderator into the nuclear reactions. So, my dear students, in the nuclear processes, huge amount of heat is produced. This huge amount of heat, when it is produced, my dear students, that heat has to be utilized. How do we utilize this heat? We pass this heat through the D2O, which is heavy water. So this heavy water D2O, the temperature of this water increases and it goes to the and it turns out to be the steam, and then this steam is utilized to run the uh, various engines or various machines. Let us say it is utilized to uh, move the cycle or move the handle of our dynamo through which we can produce the electricity. So, my dear students, to cool down the various nuclear reactors, we use water for cooling it. As instead of using the pure water as a moderator for cooling the nuclear reactors, this heavy water D2O is being utilized. Now, in the exchange reactions for the study of reaction mechanism. So, my dear students, most of the reactions takes place into the aqueous medium. Now, when the reaction is taking place into the aqueous medium, we do not understand the role of water or how does the reaction takes place and how what are in what step the reaction takes place. Now instead of H2O, suppose if we use D2O and then find out where instead of H, where do we find D? Then we can understand that what is the role of water in that particular reactions. So instead of water, when we use heavy water D2O for a particular reactions, what happens to water molecule in that reactions, we can come to know. So the way by which a reaction takes place in a various steps, it is known as mechanism. And by exchange of hydrogen, if we use the deuterium, we would come to know that how the reaction takes place or in what step the reaction takes place. Thus, to identify or just to understand the mechanism of the reactions, instead of normal water, we use heavy water, and such reactions, when we use the heavy water instead of the normal water, such reactions are known as the exchange reactions, and that help us to understand the mechanism of the reactions. Now, how can we prepare the heavy water? It can be prepared by the exhaustive electrolysis of water or as a byproduct in some of the fertilizer industries. So when we do the exhaustive electrolysis of water, my dear students, we can prepare the heavy water D2O. Electrolysis is the process of passing electricity through the water. And if it is passed through the long time, for a long period of time, if we pass the electricity, we can form D2O. It is also produced as a byproduct in some of the fertilizer when they are in the fertilizer industry. Now let us see some other use. It is used for the preparation of the deuterium compounds. So please remember, my dear students, that this is your calcium carbide. The compound is known as calcium carbide, CaC2. When calcium carbide reacts with the heavy water, it produces C2D2. What is your C2D2? Actually, it is C2H2, which is your ethine. But if it is C2D2, then instead of like in ethine, we instead of hydrogen, we have deuterium. So this C2D2 is prepared by the reactions of calcium carbide with heavy water. And remember that we also get CaOD twice. Same way, my dear students, as good as H2O, we can have heavy sulfuric acid, and this heavy sulfuric acid is prepared by allowing this D2O to react with sulfur trioxide. Same way, this is what it is known as the aluminum carbide, my dear students. And this aluminum carbide, when it reacts with the 12 molecules, each aluminum carbide, when it reacts with the 12 molecules of heavy water, it produces a very similar structures like methane. But here, instead of methane CH4, you can produce CD4. Please remember. So these are the three very important reactions, my dear students, generally asked in your final exam as to complete reaction. So I would suggest you to learn these reactions very well. And please remember that apart from this 3CD4, which is very similar to methane or heavy methane, we also get heavy aluminum hydroxides or ALOD thrice. So I will request and suggest you to learn these three reactions. Now we want to study about the dihydrogen as a fuel. My dear students, in a very space shuttles or in a space shuttles when the human being are traveling, this dihydrogen is better utilized as a fuel. Because when we use dihydrogen as a fuel, we actually produce by burning or by allowing this dihydrogen to use as a fuel, we are producing water or we may produce water. And when water is produced into the space, that can be utilized for drinking purpose. So this is how, my dear students, in space, if we use dihydrogen as a fuel, it is advantageous, especially when it comes to the traveling through the space. Now let us understand what does the text tells us about the dihydrogen as a fuel. Dihydrogen releases large quantity of heat on combustion. Combustion means addition of oxygen, and when this dihydrogen reacts with oxygen, we get water. The data on energy released by combustion of fuel like dihydrogen, methane, LPG, that is liquid petroleum gas, etc., are are compared in terms of the some amount of mole, same amount of mole, mass and volume. So, my dear students, to understand which fuel is better, we actually compare the same amount of that fuel and compare it how much energy does it produce. So we can compare it by the same amount of fuel, that means same mass of fuel, or same volume of fuel, that means 5 liter, 10 liter, 1 liter, or per liter. Now, my dear students, let us understand why hydrogen is better as a fuel option. So let us understand it. Energy released by the combustion of dihydrogen per gram is 142 kilojoule per mole. But energy released by the combustion of petrol per gram or octane per gram is 47 kilojoule per mole. So my dear students, when you compare this, that per gram of dihydrogen, the energy released is almost 3 times per gram of petrol. Thus, instead of efficiency, dihydrogen is going to be a wonderful or a very efficient fuel for us because its efficiency is almost 3 times than the efficiency of petrol. Thus dihydrogen can release more energy than petrol, almost 3 times. Moreover, my dear students, pollutants in combustion of dihydrogen will be less than the pollution that are produced when the combustion of petrol takes place. The only pollutant will be oxides of dinitrogen due to the presence of dinitrogen as an impurity with hydrogen. So whenever we produce hydrogen, it is difficult to remove dinitrogen as an impurity from the hydrogen. So when we do combustion of hydrogen, there will be some small amount of dinitrogen present uh, with hydrogen that makes the oxides of nitrogen as a pollutant. But this amount of nitrogen present into the hydrogen can be stopped by by undergoing the combustion process, and thus the pollution can be minimized. What is the process? By injecting a small amount of water into the cylinder of hydrogen to lower the temperature so that the reaction between dinitrogen and dioxygen may not take place. So from initially, if we add a small amount of water into the cylinder of hydrogen, the water decreases the temperature and thus the reaction between the dinitrogen and oxygen does not take place at lower temperature, and thus the pollutants uh, can be reduced, or the amount of pollution can be, or amounts of pollution can be decreased. Now, what is the problem using dihydrogen as a fuel? So the first problem that comes using the dihydrogen as a fuel is storage. The storage of dihydrogen is very difficult in gaseous state because it occupies a large volume, and so instead of storing this dihydrogen in the gaseous state, it is stored into the liquid state. A cylinder of compressed dihydrogen. You know, when we want to convert it into the liquid, it has to be compressed. Even if we want to store it into the gases, it will occupy a large volume, so we need to compress it. So the compressed dihydrogen weighs about 30 times as much as the tank of petrol. This is very important point. So when we compress the dihydrogen, the weight of the tank is very high, because when we compress it, we need a very thick wall of the tank, because that is the only way by which we can handle the compressed or high pressure dihydrogen. And to bear the pressure, we need a very heavy metal containers. So the container in which the dihydrogen can be stored, they are highly, they are highly having very high masses. So the petrol tank is, suppose we have 1 kg petrol tank storing 1 liter of petrol, then we need at least 30 kg tank that to store 1 liter of our hydrogen gas, which is compressed. Please remember that the mass of the tank in which the hydrogen is stored is almost 30 times heavy than the tank that we use for our petrol. Also, the petrol that containing the same amount of energy. So my dear students, if we want to get the 1000 kilojoule per mole of energy from hydrogen, and 1000 kilojoule per kilojoule per 1000 kilojoule energy, not per mole. If we want to get 1000 kilojoule energy from hydrogen and 1000 kilojoule energy from petrol, for that suppose we need 1 liter petrol and X liter of hydrogen, then both these volumes, 1 liter of petrol we store in a tank, if it weighs 1 kg, then to store the X liter of hydrogen, we need at least 30 kg of tank for hydrogen. Also, my dear students, also dihydrogen is controlled or is converted to liquid by cooling it at 20 Kelvin temperatures. So my dear students, if we want to convert dihydrogen in a liquid state, we will have to cool it for about 20 Kelvin temperature. Now please understand, my dear students, that your 273 Kelvin is your 0 degree centigrade temperature. So when you want to cool it to the 20 Kelvin, you need to make the temperature of minus 253 degrees centigrade. So my dear students, for converting dihydrogen into the liquid, we will have to cool it to the minus 253 degrees centigrade temperature. This would require expensive insulated tanks, so that we can store this hydrogen at minus 253 Kelvin, or we can convert, or we can decrease the temperature of hydrogen up to minus 253 degrees centigrade. Thus the storage tanks, or the tanks which is used to cool down the hydrogen, they are very expensive and they are very heavy. Alloys used to make the storage tank for hydrogen. See, we cannot make the normal alloys or normal metal. We cannot use normal metals or normal alloys to store hydrogen. But we need a special kind of alloys like the Na Ni5 alloy, or Ti2 alloy, or Mg2 alloy. These kind of alloys are used, which may be expensive, or their density is very high. The second problem that arises is the problem of transportation. As these tanks are very expensive, insulated and heavy, maintenance of these tanks and transport of these tanks are very difficult and very expensive. So scientists, due to the above limitations, have been looking for or doing research for alternative techniques to techniques to use dihydrogen, or alternative techniques to use dihydrogen in more efficient way. So the scientists are trying to find out, trying to research on the area where we can use or store or transport dihydrogen in some other ways. Now, the last point of this chapter is known as the hydrogen economy. So let us understand about hydrogen economy. What is hydrogen economy? Hydrogen economy is an alternative. So hydrogen economy is the alternative or alternative method by which we can utilize hydrogen as a fuel in a better or efficient manner. Under hydrogen economy, use of hydrogen as a fuel is appreciated and promoted. So the various countries or various governments, they appreciate and promote the use of hydrogen as a fuel by under the hydrogen economy. Hydrogen economy prefers hydrogen to be used as a fuel directly in the liquid or gaseous state, but not as an electric power. So, my dear students, under hydrogen economy, it is important to use hydrogen as a fuel directly, but not by using hydrogen by like the hydrogen economy do not prefer the use of hydrogen to produce electricity and then electricity is used as a power. Because if hydrogen is used into production of electricity and then when electricity is used as a fuel or when electricity is used as a to do work, lots of energy is being wasted in this process. And that is why this hydrogen economy prefers to use hydrogen directly as a fuel. Now, it is economical also when a fuel is directly used as a fuel, it is also economic or it requires less amount of money to utilize this particular fuel. And thus, the hydrogen economy prefers to use hydrogen directly as a fuel, but it does not prefer the use of hydrogen to first produce electricity and then this electricity is used for doing some work. In the year of 2005 or in the October 2005, a pilot project was introduced to launch hydrogen as a fuel in running automobiles. So, my dear students, whatever the automobiles are running here, our Indian government has used hydrogen as a fuel for them. Initially, what the government has planned that 5% hydrogen gas has been mixed with the compressed natural gas CNG. So whatever CNG we have been using, it contains 5% of hydrogen and that can be utilized directly into the various automobiles if they are having CNG engines or if they are having the engines which can run with the CNG. Thus, my dear students, all CNG have 5% hydrogen with them. For use in a four-wheelers vehicles, the percentage of dihydrogen would be gradually increased to reach the optimum level and various research have been done in this direction under the name of the hydrogen economy. Now, a next point, my dear students. Nowadays, hydrogen is also used in the fuel cells. Now, fuel cells are the cells that produce electricity using hydrogen directly as a fuel. That you will study into the 12th standard. If you want to look about the fuel cell, you can go to the third chapter of 12th standard, and in the last portion, you will come to know about the fuel cells. These fuel cells are also very efficient. Their efficiency is more than 60%, and they are also pollution free. So, my dear students, nowadays hydrogen is also used as a fuel into the fuel cells for the generation of electric powers. Now, what do we expect? It is expected that economically viable and safe sources of dihydrogen will be identified in the years to come in the future for its use as a common source of energy. So we should hope, we should do research, my dear students. If you develop or you become a scientist, uh, I would suggest you or request you to find out those various ways by which we can use this hydrogen as a fuel or hydrogen as a common source of energy. That is what it is expected from you when you become a researchers or when you become a scientist or when you become an engineer, develop an engine that really make hydrogen to be used as a fuel. And this is how we can help the nations, help the world to have a pollution free use of the energy or pollution free production of the energy. So, my dear students, here we complete the discussion about the chapter hydrogen. If you have any doubts, you can ask me. बच्चों, अगर आपको कुछ पूछना है तो आप पूछ सकते हैं.